In this module, I will discuss on polygeneration. From the module of energy conservation, we get a concept of polygeneration. In general, polygeneration is a process which produces two or more different products but not a cogeneration or trigeneration process. Apart from electricity, products may be chemicals or fuels. We will learn how to integrate various processes in a single unit to obtain multiple utility efficiently. What are the advantages and disadvantages of polygeneration? From previous modules, we have identified major challenges regarding energy sector. Now, we will revisit on few of them before entering to the polygeneration. Major challenges of energy sector are reducing greenhouse gas emission to mitigate climate change, because anthropogenic greenhouse gases emitted from energy sector contributes to global warming mostly. This happens due to combustion of fossil fuels for power generation. Then, increasing energy security through local resource utilization is another challenge, as utilization of local resources reduces dependency on fossil fuels and increases energy security of local people. Another challenge is developing efficient energy conversion system. It increases energy efficiency and reduces resource consumption as well as reduces harmful emission to the environment. Another challenge is linking local supply and demand. This may be done through decentralization of plants. However, decentralized or distributed plants should be designed according to available local resources and local utility demand. This linking supply and demand reduces transmission and distribution losses of inputs and outputs and also enhance the usefulness of the plant to locality. I will discuss about decentralized plant later. Energy demand at end use may reduce, enhancing energy efficiency in demand side through energy efficient devices. For an example, use of LED lamp instead of traditional bulb reduces electricity demand. Identification of new energy resources is crucial from the viewpoint of fossil resource depletion. After identifying new resources, say biomass or solar energy, developing suitable technology for energy conversion of those resources is important. In energy conversion and supply chain, there are mainly three steps. One is finding energy resources, then developing conversion technologies according to resources, and linking those conversion technologies with end use of utilities, or it may be in reverse way. In the left column, resources are identified. They are solar energy, wind energy, biomass, coal, petroleum, water bodies, etc. In the right column, end uses are shown. They are transportation fuel, electricity, chemicals, drinking or processed water. In between these two, several conversion technologies are available. We have to choose according to resources and end use of utilities. For an example, where solar energy is to be used for electricity generation, photovoltaic may be an option. For biomass to transportation fuels or biomass to chemicals production, thermochemical, biochemical, catalytic processes or polygeneration processes are available options. These options should be chosen from technological, environmental and socio-economic viewpoints to be a sustainable solution. In a power plant, electricity is produced from fuel energy. At the same time, effluents are rejected to the environment in forms of flue gas, wastewater or hot water. Similarly, electricity and utility heat produced in cogeneration plant. When 3 outputs are produced in a single plant, that is called trigeneration plant. These outputs may be electricity, cooling and heating. When multiple utilities are produced in a single plant from one or multiple resources, that plant is called multi-generation or polygeneration plant. Now question is, what polygeneration is? Let's illustrate through figures. Figure A is a power plant for electricity production. Figure B is the plant for utility heat production. Figure C is desalination plant for producing water. And figure D is the refrigeration plant for chill. These are individual standalone units. Figure E is the polygeneration plant for producing those utilities in a single plant. Thus, polygeneration is the optimum process integration for delivering multiple utilities from a single unit to obtain an efficient multi-utility system. There are several benefits of polygeneration and will be discussed later. Now, question is, how we can integrate different processes in a system? We can integrate this process according to maximum thermodynamic output, or we can integrate according to socio-economic condition of the consumers, or the objective function may be a combination of these. These things will be discussed later. Polygeneration can be established in centralized or decentralized way. In decentralized plant, lower capacity plant are located in different position of supply area. However, for centralized plant, larger capacity plant are located in the center of the catchment area. If polygeneration plants are based on local resources and these local resources are available in dispersed or scattered way, then decentralized plant is preferred. Output of the polygeneration plant should cater to local needs, as transmission and transportation of utilities are not feasible option for distributed plants. For an example, a polygeneration plant fueled by locally available biomass should be a distributed plant. On the other hand, if available resources are in concentrated manner and energy density is higher, centralized polygeneration plant would be preferred. For an example, a coal-based polygeneration plant should be a centralized plant of larger capacity. As I discussed earlier, for distributed plants, utility output should cater to needs of local people. Also, output utilities should be designed according to input fuel type and demand of utilities. Utility outputs from the polygeneration plant may be electricity, process it at high temperature, process it at low temperature, cooling, hydrogen, alcohols, biofuels, byproducts from elemental sulfur, CO2 for recycle and utilization. This utilities production process should be integrated according to enhance the performance of polygeneration plant in terms of thermodynamic, socio-economic and environmental parameters. Now, we have identified that there are plenty of energy sources are available in nature, and outputs are also many. For different energy sources, conversion technologies are also different. Hence, there is a scope of optimization through superstructure as shown in the figure. Objective function of this optimization may be thermodynamic, economic, environmental or combination of these. Optimization helps to increase the performance, reliability and acceptability of the polygeneration. When multiple energy resources are available and in demand side, utilities are also multiple with different demand pattern, there should be an intelligent management system. In figure, an example of intelligent demand side management is shown. Solar, wind, biomass are energy sources and there is the option of energy storage. Household, industrial electricity, hydrogen for fuel cell, vehicle charging and water are in demand side. Their demand pattern and magnitude are also different. For example, industrial and household electricity demand pattern is not same. Hence, intelligent demand side management is required to supply these utilities efficiently. However, these supply side renewable energy sources are also available intermittently. Proper energy management system may reduce this problem by interacting with intelligent demand side management. There is a question, why we go for polygeneration when there are standard processes of utility productions? It has several advantages. Advantages of polygeneration are: polygeneration increases energy efficiency through process integration, gives fuel energy savings, that is, conserves resources through heat and mass integration, reduces water consumption and minimize waste to environment, decreases CO2 direct emission through polygeneration with CO2 capture and utilization. It gives better cost effectiveness. Hence, better sustainability can be achieved through polygeneration. It has several disadvantages also. They are: it increases the complexity of processes, increases interdependency between different processes within the polygeneration, and assessment of polygeneration can be done by these equations. These parameters may be objective functions during optimization of a polygeneration. One is energy efficiency. Energy efficiency is the ratio of energy equivalent of utility outputs to energy input in different form. Another is exergetic efficiency. Exergetic efficiency is the ratio of exergy output utilities to input utilities. As decentralized polygeneration are designed to fulfill local energy demand, the usefulness of polygeneration should be tested by the following equation. It is measured in terms of production rate of utilities, demand and price of utilities. When a polygeneration is designed for CO2 capture and utilization, then CO2 utilization factor may be used to see the economical effectiveness of polygeneration. It is the ratio of price of utility outputs, including value-added products of CO2, subtracted by reduction in CO2 mitigation cost, to the price of utility outputs without CO2 capture. It evaluates the benefit of utilization instead of CO2 sequestration. For polygeneration, with liquid or gaseous fuel production, carbon conversion efficiency is an assessment criteria. It is the ratio of carbon output through liquid or gaseous fuels to the carbon input through solid fuels. There may be other kind of assessment criteria according to objective of assessment. Objective may be used for optimization, for taking decision on environmental effect, or may be test of economical benefit of polygeneration. Objective function may be multi-objective. However, various challenges have to face for polygeneration. These challenges are supply-demand matching through proper energy system design, intelligent monitoring and controlling, and of course sustainability assessments of different polygeneration system. And last but not the least, the system optimization. Thus, polygeneration may be a sustainable solution if we solve these challenges effectively. Thank you.